The cross product is also distributive over addition, and suppose I have a vector A x with in this x component form x1 I cap y1 j cap plus z1 k cap, vector B as x2 I cap plus y2 j cap plus z2 k cap, and I have to evaluate A cross B. So I have to go in the same manner, x1 I cap plus y1 j cap plus z1 k cap cross x2 I cap y2 j cap plus z2 k cap. So I use the knowledge that I cross I will vanish, it will be 0. I cross j will give you k cap, I cross k will give you minus j cap, and so on. You can multiply in this way. There is a smarter and simpler way also. You can use the determinant to evaluate this. You have I, j, k, x1, y1, z1, x2, y2 and z2. And this determinant will give you the same result as you can obtain by direct multiplication. So this is a unique way for multiplication of two vectors. Before we discuss geometrical meaning of cross product of two vectors, let us recall that what is the area of a parallelogram? Area of parallelogram is base into height. That means you can, in this picture, you can say OA into CP is the area of parallelogram. Let us try to evaluate this area of parallelogram ACBO. Area of parallelogram OACB. This will be base into height, and you can say it can be written as OA into CP. Also, we consider this triangle ACP. In this triangle ACP, using sine theta, you can find out in triangle ACP, sine theta will be perpendicular upon hypotenuse, that is CP upon AC. And this will give you this AC is also B vector, and AC vector is, so magnitude of AC will be mod of B vector upon CP is equals to sine theta, and finally you have CP equals to mod B sine theta. What is OA? OA is mod A, magnitude of vector A. And what is CP? CP is mod B sine theta. And what is this? This is magnitude of A cross B. Do you remember? A cross B is vector A mod into mod of vector B into sine theta into n cap. So geometrical meaning of cross product is its magnitude gives you area of the parallelogram. If the two adjacent sides of a parallelogram are represented by vector A and vector B, then its area is given by magnitude of vector A in cross B. A very important fact now I want to discuss with you. If you have vector A and vector B given to you, so the vector A cross B will be always perpendicular to vector A. A cross B will be always perpendicular to vector B. The cross product is always perpendicular to two given vectors. So using this fact, you can conclude one thing: to find any vector perpendicular to a vector A and vector B, that is perpendicular to two given vectors, you will evaluate K times A cross B. Obviously, there is another condition given to you by which you can find out K. But this is very important to know and to remember. To find any vector perpendicular to two given vectors, you can evaluate K times A cross B or B cross A. Thank you. Now let us consider a few questions. So the first question, I have taken the 13th question of exercise 7.3 and on page number 448. there is something given to us, that is magnitude of vector A and magnitude of vector B and magnitude of vector C are equal, and all three are equal to 1. One more thing is given to us, that A plus B plus C is equals to 0. So these two things are given to us, and we have to find A dot B plus B dot C plus C dot A. This is what we need to find. So let us use the property of dot product, and we begin with this, what is given to us. So you have A plus B plus C equals to 0. You can apply A plus B plus C dot A plus B plus C equals to 0. You can use the dot product, so it will be multiplied with all these. So you have this whole multiplied with A vector, this whole multiplied with B vector and C vector, and so on. So finally you have vector A dot vector A, that gives you magnitude of vector A square. A dot B, you have vector A dot vector B. You have A dot C. You have B dot A. You have B dot C. And you have B dot B. So B dot B is vector mod vector B square. Now C is multiplied with all these three, so you have C dot A and C dot B and then C dot C, that is mod C square. So after evaluating these, in RHS you have 0.0, that is equals to 0. So on evaluating this is mod of A square plus mod of B square plus mod of C square. We know that vector dot product is commutative. Dot product of two vectors is commutative. So you have 2 times vector A dot vector B plus B dot C plus C dot A equals to 0. The values mod A, mod B, mod C is given. It is 1. So you have 1 plus 1 plus 1 plus 2 times this A dot B dot plus B dot C plus C dot A equals to 0. So the value of A dot B now easily can be calculated, plus B dot C plus C dot A will be equals to minus 3 by 2, and this is your answer. Consider this 6th question of the miscellaneous. In this case we have given vector A and vector B, and we have to evaluate a vector of magnitude 5 units in the direction of resultant of vector A and B. So what is the resultant of vector A and B? Resultant of vector A and B is vector A plus B. So first of all we have to find out what is A plus B. So vector A plus vector B is 3 I cap. We add the respective components, 3 minus 2 j cap and minus 1 plus 1 k cap. So this is a vector in the resulting vector A plus B. Now in this direction we have to evaluate a vector of magnitude 5 units. In this case we are using the concept of multiplication of a vector by a scalar. When you multiply a vector by a scalar, its magnitude becomes that much times by which quantity you are multiplying. So in this direction we have to find out first unit vector. So let us consider this as vector C. So you have unit vector C cap can be written as C vector divided by magnitude of C, and that will be given as 3 I cap plus j cap divided by square root of 9 plus 1, that is root 10. Now we want to evaluate a vector of 5 magnitude in the direction of a plus b. A vector of 5 magnitude and in the direction of a plus b will be given by 5 times c cap, because whenever we multiply by 5 its magnitude becomes 5 times, and c cap, it has magnitude 1 unit, so as a result its magnitude becomes 5 units. So this is your required vector and this is your final answer. Now let us take this question number 8 of the miscellaneous. We have 3 points A, B and C, and we have to prove that these 3 points are collinear. The points are given, that means their position vectors are given. So you have OA vector is I cap minus 2j cap minus 8k cap, while OB vector is 5i cap minus 2k cap, and OC vector is 11i cap plus 3j cap plus 7k cap. Now we evaluate AB vector. So you know you have final minus initial, so it is OB minus OA, and that will be given by 4i cap 0 plus 2j cap, and it is plus 6k cap. Next we evaluate BC vector. So you have BC vector as 11 minus 5, 6i cap, 3 minus 0 plus 3j cap, and 7 minus 2, that is 9k cap. So if you see here, so 4 by 6 it is 2 by 3, 2 by 3 is 2 by 3, 6 by 9 is 2 by 3. What we are doing, we are finding the ratio of I, j and k components. So they all are equal. The ratio of this x component is 2 by 3, y component is 2 by 3 and z component is 2 by 3. So you can write it down as BC vector equals to 3 by 2 times AB vector. Therefore, you can conclude that BC